Okay, today is section 3.6, and this is gonna end our chapter on chapter 3 on inverses. Hopefully by Friday, we're gonna take some kind of a test on 3.5 and 3.6. I checked your tests from 3.4, 3.4a, they were excellent. I was really happy with them. I haven't put the grades yet in Power School, but I will be doing that today during the hour. But today what you're going to be doing is you're going to define inverse relations and functions. You're going to find inverse relations from tables, graphs, and equations, and you're going to determine whether an inverse relation is a function and verify inverses using the composition. We're going to do all that today. We may have to finish it on Wednesday though if we don't finish all this. Okay, so step one is let's review what, if you have a relation, this is a relation, it's a set of ordered pairs. We have set notations here. This is some kind of a relationship. If I asked you to state the domain, what is the domain? The domain is all of your x values. These, I'm circling them all. So in your relation, your domain is all the x's. How do you state the domain? Well, you were taught in freshman year, put a D, you can write domain. But what you do is organize your x's in order from least to greatest and don't repeat. So your domain is going to be 2, and separate them with commas. 2, then we're going to write a 4, then we're going to write a 6, and then we're going to write an 8 and a 12. Now if I asked you, is this relation a function? What would you say? Yes. Why is this a function? Because for every x there's only one y value. There's no x values that are repeating. Now for the range is all your y values. And again, how do you do the range? You're going to do your bracket, and it's all the y values, the stuff that's not circled, and you're going to put them in order from least to greatest. So I would start with the 3, then I would write the 5, and then the 7. I do not write it twice, and then 20. Now, if I ask you what's the difference between opposite and inverse, opposite, the word opposite is change the sign. But inverse is when you switch these two. When you invert something, you're going to switch these two around. So that's what we're working on here. So if you look at example 3, and by the way, what they did, here's an example right here. The inverse of 1, the point 1, 2 is 2, 1. The inverse of 2, 4 is 4, 2, and the inverse of 3, 6 is 6, 3. All you do, the inverse means you take the x and the y and you switch their spots. So basically what's happening here is your domain will become your range and your range will become your domain. That's it. So using this little diagram that I have here, tell me what is the domain and the range of this relation. It is 0, 2, a 4, and an 8. So 0, 2, 4, and 8, and the range is a 1 and a 3. So if I ask you what's the domain and the range of the inverse, well, you'd have to switch these 2 points around. What's going to happen? Your domain is going to be your 1 and your 3, and your range is going to be your 0, 2, 4, and 8, just like that. Okay, so for this next example right here, I want you to plot these 4 points. 0, negative 5. Where is 0, negative 5? And 1, negative 4, and 2, negative 3, and 3, negative 3. Now normally you don't connect the dots, but I'm going to have you connect them for this problem. Connect them. Okay, So this is the relation, this is the function t. That's t. Now let's see what the inverse looks like. So how do you do inverse? You switch your x and your y. So negative 5, 0, negative 4, 1, negative 3, 2, and negative 3, 3. I want you to graph these points. Over 5, 1, 2, 3, 4, 5, negative 4, 1, negative 3, 2, and negative 3, 3. Whoops, this should be negative 3, this should be a 3. I knew I made a mistake. Negative 3, this should be a, wait, negative 3, 2, and negative 3, 3. This is right. Negative 3, 2, and negative 3. Oh, right here. There it is, right there. Okay, now connect them. And this is called the inverse. Now, when we write the inverse, we use, it looks like to the negative 1 power. So this is t to the negative 1 power. That means that's how you designate inverse. So here's the function t, and here's its inverse. What you're going to notice, remember last week when we did symmetry? Inverse functions, or inverses I should say, shouldn't say function because this is not a function, has symmetry to the line y equals x. Where's the line y equals x? It's right here, I'm drawing it. This is the line y equals x. If I were to fold my piece of paper along this line right here, y equals x. If I were to fold that like that along this line, what do you notice? That this and this land on top of each other. They're symmetrical. If I were to do that, sometimes we'll draw like a little, we'll darken it and then draw it and then scratch it like that, and you'll see the image. So inverses have symmetry over the line y equals x. So that's another type of symmetry that you need to know. Okay, let's do another example. Look at the back. If you're given a function or a relation with an equation, not a table now. Now we're going to look at an equation. How do you find the inverse of an equation? What you do, well, if you take the x values in a table and make the x value the y value, and the y value becomes the x value, well, you do the same for an equation. What you're going to do is make the x value the y value and the y value the x value. So in this problem, see how it says y equals 2x plus 8? Instead of y, you're going to write x. X equals 2y plus 8. X equals 2y plus 8. And now what you must do is solve that equation for y. Get y by itself. So how would I solve x equals 2y plus 8? How would I solve this for y? I'm going to subtract 8 and divide everything by 2. So y is equal to, I'm going to write 1/2 x minus 4. But what I should do here is put this negative 1 here to show that that's the inverse equation of y equals 2x plus 8. Okay? Check out, here's a table. If I gave you a function y equals 2x plus 8, and I asked you to graph it, one of the ways you would graph it is pick some points. So these points were picked for you, -6, -4, -2, and 0. If you were to plug -6 in here, you're going to get -4. You can just do it. -6 times 2 is -12 plus 8 is -4. If you plug -4 in here, you're going to get 0. If you plug -2 in here, you're going to get 4. And if you plug in 0, you're going to get 8. So let's plot these 4 points, and it's a linear function so we can connect the dots. So plug in -6, or graph -6, and these are going by twos. -6, -4, -4, 0, -2, 4, and 0, 8. So let's connect these dots right here. Okay? And now, what would be the inverse? Well, the inverse is you take your x values are going to become your y values. So each of these points you're going to switch. -4, you're going to have -6, 0, -4, 4, -2, and we have 8, 0. Let's plot these points. This is the inverse of that. So it's the inverse function. So we're going to do -4, -6. There's -4, -6. Then 0, -4. Then 4, -2. And then 8, 0. And we're going to connect these dots. Now remember that little symmetry thing I told you? If they are inverses of each other, you should be able to look at the line y equals x, which is this line y equals x. And if you were to fold your graph over that line, would they line up? What do you think? Do they line up? I didn't fold it very well, but does this side line up with that? And it sure does. So you should be able to check for the symmetry if you can take one, fold it over the line y equals x, just like when we did even functions. Even functions, what you did was you folded over the y-axis, and when if it had symmetry to the x-axis, you folded it on the x. And in this one, you fold it on the line y equals x, and that's what tells you that you have an inverse. Okay? All right, next. Let's do another one of these. They're going to ask you to compose the inverse of a function. Here is a function. It's called g of x is equal to 4 over x minus 2. If you see this notation, what does that mean? This notation means find the inverse. I want the inverse. How do you find the inverse? What you do is you switch wherever you see an x, you put a y, and wherever you see a y, you put an x. And then you resolve it for y. So now, where is your y value here? I see an x, but what's the y value? What's the y value? G of x is the y value. So you start off like that. And then what you do is you put, wherever you see your y, you put an x, and wherever you see your x, you put a y. Now, how do you get y by itself? There's a couple things you could do. You can multiply by the reciprocal. Okay? You can do that. Or some people like cross multiplying. I think let's try cross multiplying. If you multiplied the 4 times the 1, you get 4, right? And what is x times y plus 2? It's x times y plus 2. Do not distribute. Divide both sides by x. So you have, right now, you have 4 over x equals y plus 2. And now how do you get y by itself? Subtract 2. Now instead of writing y, you're going to write g negative 1 of x. So 4 over x minus 2 equals g negative 1 of x. Because they made their y value g of x, and so this notation means that this is the inverse of that. Okay, let's try another one. So, g of x is going to be the inverse of this. Well, how do you find the inverse? You take x and y and switch them. and solve it for y. So add 2 and divide by 3. So x over 3 plus 2/3 is equal to y. That, they want you to call this g of x, which is the inverse. Now, I think what you should do, instead of calling it g of x, I think you should call it f negative 1 of x. Because that tells me that that's the inverse of that one. Okay? Now, look at the bottom, because we're slowly running out of time. If I asked you if these functions, I'm going to make up some functions. Is this a function, yes or no? Is it a function? How do you know it's a function? Vertical line test. Yes, this is a function. So if it's a function, I can write f of x. And it's the absolute value. What about this? Is this a function? So I can write, call that x squared. Is this a function? I could call this f of x equals x plus 2. Okay? So, these are actually relations first. If they're functions, if they pass the vertical line test, then instead of writing y equals, we can say f of x because it has it's a special type of a relation. So if your relation passes the vertical line test, we write f of x, right? What about this one? We did this in one of our chapters. Is that a function? Yep, f of x equals x cubed something. Okay? In this one, that's a function. F of x equals whatever it is, x cubed. That's actually, this is going to be more than x. This looks more like the parent function. This might be plus 2x minus 1. Okay? I'm just making this up. So, if a relation passes the vertical line test, we can use f of x. But how do I know if when I do the inverse of this, when I do the inverse of this, it's going to be f negative 1. How do I know if its inverse is going to be a function? Well, if it passes the horizontal line test. Because remember, when you find the inverse, you switch things around. So instead of the vertical line test, we do this horizontal line test. So if you were to draw a horizontal line through this, if it hits at one place, its inverse will be a function. This inverse, when I flip it over the line y equals x, the inverse of this is not going to be a function. So unless I restrict the domain, I can't use that notation. For that one, the inverse is not going to be a function for this one. I can't do this for that one. For this one, it's going to work. I can do that when I switch x and y. This one won't work. This one will. It just depends. Okay? Okay? So, in this next set, they talk about one-to-one. Here they use the graphing calculator. This is A graphed, this is B graphed, and this is C graphed. Out of these three, this one and this one will be functions. Barely this one. This one is not. It's not one-to-one. This middle one does not pass the horizontal line test. Okay? So, we're going to talk about restricting the domain on Wednesday. But how do you know whether two functions are inverses of each other? We'll talk about this on Wednesday.